Respected my class in charge and my dear friend, first of all, I say very great morning to all of you.
Very great morning, Tanu.
Myself Tanu from Proud 12 Science. Today I am here to call Anshu for speech. You know very well that birds move the world. One can melt island by the power of the word. Now the turn goes to Anshu for speech. So let's welcome Anshu.
Respected my class in charge and my dear friends, a very great morning to all of you.
Very great morning, Anshu.
Myself Anshu from Proud 12 Science Standard, and today I am here in front of you to deliver speech, and my topic for speech is transformer, which is related to our subject physics. I hope you all have heard about the word transformer, and today we are going to discuss about this word in brief. Transformer is a device which is used to convert low alternating voltage at high current into high alternating voltage at low current and vice versa. It is based on the principle, or it works on the principle of mutual inductance. What is mutual inductance? It is defined as if we take two coils which are inductively coupled, and if magnetic flux get changed in one of the coil, then induced EMF will be produced in the another coil. Now about the construction of transformer. Transformer consists of two coils which are insulated from each other, and they are wounded over a soft iron core. Soft iron core is laminated for purpose to minimize the value of eddy current, and we will discuss about this in brief after a few moments. One of the coil is called primary coil, and it consists of number of turns denoted by Np, and other is the secondary coil and number of turns denoted by Ns. Primary coil is the input coil, while secondary coil is the output coil. When AC, or we can say alternating current, is applied across the primary coil, then we get transformed output from the secondary coil. That is why primary coil is called input coil and secondary coil is the output coil. Let's move to the types of transformer. As I have told you in its principle, like whenever magnetic flux linked with the coil get changes, then induced EMF will be produced in the another coil. The value of induced EMF will depend upon the number of turns present in the coils. So based on the number of turns, there are two types of transformer: step up transformer and step down transformer. In step up, the number of turns present in secondary coil is greater than number of turns present in primary coil. So primary coil is made up of thick insulated copper wire, while secondary coil is made up of thin insulated copper wire. What is the work of step up transformer? It basically converts low voltage at high current into high voltage at low current. In step down transformer, the number of turns in primary coil is greater than number of turns in secondary coil, and primary coil is made up of thick insulated copper wire and secondary coil is made up of thin insulated copper wire. What is the work of step down? It basically converts high voltage at low current into low voltage at high current. Let's move to the theory of transformer. When alternating EMF is applied across the primary coil, the voltage keeps on changing in the primary coil, and due to this, magnetic flux also get changed in the primary coil, and the magnetic flux got linked with the secondary coil, and as a result, induced EMF will be produced in the secondary coil through the soft iron core. So we can conclude that the magnetic flux linked with the two coils is directly proportional to the number of turns present in the coil. So we can mathematically define it like the ratio of magnetic flux present in the secondary coil to primary is equals to number of turns present in secondary coil to primary coil. And on further calculations, we will find our result that induced EMF in secondary coil is equals to Ns upon Np into induced EMF in the primary coil. As I have told you earlier that Np stand for number of turns in primary coil and Ns stand for number of turns in secondary coil. Transformer is based on the principle of law of conservation of energy. It means that it neither creates nor destroys. It simply changes the voltage or current from one form to the another form. Now, a very important question arises that what is the need for lamination of iron core? That we have discussed earlier that iron core is laminated in that. Why so? When alternating current is passed through the primary coil, then magnetic flux get changed and it linked with the secondary coil and induced EMF is produced in the transformer. The flux got linked with the soft iron core also, and as a result the induced EMF developed in the soft iron core. It would now about the very important question that what is the need for lamination of core. As we had discussed earlier that it is used to minimize eddy current. What is this eddy current? We are going to discuss about this. When alternating current is passed through the primary coil, magnetic flux got changed and it get linked with the secondary coil. As a result, induced EMF is produced in the secondary coil. The induced EMF is also produced in the soft iron core, and the induced EMF developing iron core produces current in the core in the form of closed loop. This is known as eddy current, and as the resistance in the transformer coil is very less, so as a result eddy current will be produced in large amount. As a result, large amount of heat will be produced and it would reduce the efficiency of transformer. So to minimize the value of eddy current, we just laminated the soft iron core. There are many energy losses take place in the transformer. The efficiency of transformer is not 100%. There are many energy losses like flux loss, copper loss, hysteresis loss and humming loss. We will discuss about them in brief. Humming loss. Whenever alternating current passes through the iron core, it produces some vibrating sound, and in the form of sound, some heat is lost, and this is also the loss of is an example of heat. The efficiency of transformer is not 100%. There are some energy losses take place in the transformer like flux loss, copper loss, hysteresis loss, and humming loss. Humming loss is very simple, as whenever alternating current passes through the soft iron core, it will produce vibrating sound, and in that vibrating sound will release some heat, and as a result energy is lost in the transformer. Second is flux loss. In the transformer, flux is not completely linked with both primary and secondary coils, so as a result in that form also energy is lost in the transformer. Hysteresis loss. The area of hysteresis loop for soft iron is narrow, so as a result it would be best for making transformer. There are some energy losses take place. Thank you and have